an inverse function reverses the effect of the original function. So if you've got some function, then the inverse of it we would write as f to the minus 1 of x, which is different to indices. It doesn't mean do 1 over x, it just means the inverse function. So keep an eye out for that one and make sure you don't get caught out by it. It means that if you do f to the minus 1 of f of x, so inverse f of x, then you would get out x. It means you would do the function of x, and then you would do the inverse to whatever your output was, and you should get back to your original input. That's how it works. So one way of looking at it is like this. You could take your, so we'll have f of x is 2x plus 5. So you're taking your x value, and then you are multiplying it by 2, and then you are adding 5. And what you get out is your output, okay, which will be your f of x value or your y value, depending on how you've written it. If you then do that backwards, so you put your output back in again, and you do the opposite, then you should get back to x. So the inverse function, in this case, would be, now here's where it gets slightly confusing, because we put x here as well, just to really mess with your heads. You can put whatever you like. You can put g or x or whatever it is that you want to do, but we normally put x because that's just the convention. So it's worth getting your head around for now. So for this, we'd do x minus 5 and then divide it by 2, and that would be our inverse function of x. So it means whatever you put in, you do that to it, and that should reverse what this function has done. Okay. So another way to do it is to write it in terms of x and y. So we would put, let's go with, if g of x is 2x minus 1, then we put y equals 2x minus 1, and we rearrange it. So we say y plus 1 equals 2x, having taken that over, and then we would divide through by that. Okay, so we could say that that would be our inverse function. Now at the moment we've got it in terms of a y, however what we would normally do is we would normally put the inverse function of x is equal to x plus 1 over 2. So rather than using the y, we tend to stick with the x just because it's convention. Okay, it doesn't matter, it's not the end of the world, but x would be the best way to go. Okay, so let's have a look at what happens if we do something slightly different. So let's try and do the inverse of, if we have f of x is x squared, let's try and do the inverse of that. So you take your x value, you square it, and you get your output, right? So if you take your output, the opposite is to square root it, but then actually what you'd end up with is plus or minus x. So for example, if we took a value of 3 and we squared it, we'd get 9. But if we square root the 9, using our potentially inverse function here, then we could get plus 3 or we could get minus 3, which means that you actually can't write an inverse function for this function here. And the reason for that is because that is a many-to-one function. Many-to-one functions, because more than one input can give you an output, it means you can't then put that output back in and predict which input it was that gave you that in the first place. So many-to-one functions you can't find an inverse for. One-to-one functions you can. So worth remembering is that the domain of the inverse is the same as the original range of the function. Okay, so the domain of the inverse is the range of the original function. Okay, what I'd suggest you do now is try plotting some of these graphs and their inverses on the same set of axes and see if you can see the relationship between what the function was and its graph and the inverse graph. So I would suggest you do x plus 2. So find the inverse and plot, so let's go with, if that's f of x is x minus 2, plot f of x and inverse f of x on the same axes. And I want you to see if you can find what the relationship is between those two things, okay? That is your bonus question for today. So they're the 3 graphs I'd like you to have a go at. And in order to define my function properly, I'm also going to tell you the domain. So for each of them we'll just make it nice and easy. X belongs to the real numbers. And I want you to give that a go and bring it with you to class so we can compare notes and see what we found. So find the inverse of each function and plot the function and its inverse on the same axes, and we're going to see if we can see the relationship between the two things.